Mission Station on Space to Ground.
3D printing in zero gravity. Welcome to Space to Ground. I'm Gary Jordan. It can be quite a hassle to ship tools to space and could take months or even years of planning and execution. So why not just make the tools in orbit? Jeff Williams used a 3D printer on the International Space Station this week and popped out a few samples called coupons. These coupons help demonstrate the composition of the print material when used in space. Researchers print a duplicate copy of the coupon on the ground to compare dimensions, layer thickness, adhesion, strength, and flexibility to the ones in space. Having 3D printing in space provides on-site and on-demand manufacturing capabilities and reduces the need for shipping spares on cargo vehicles, saving a lot on time and cost. Williams continued work on three-dimensional objects on the station this week with satellites called spheres. These bowling ball-sized robots fly within the cabin of the space station and contain their own power, propulsion, computers, and navigation equipment. They test out spaceflight maneuvers and tasks on a small scale inside the space station. Researchers upload algorithms and programs for the astronauts to execute on the spheres and run autonomously to see how the satellites behave in the microgravity environment. Sphere simulates space operations like automatic rendezvous and docking of space vehicles, formation flight patterns, and remote operations, and can be adapted with more equipment to conduct experiments like studying the behavior of liquids or creating 3D models of objects to interact with. This week's question comes from Jim, who wants to know the speed of a spacecraft entering the Earth's atmosphere and the temperature inside. For this question, let's use the recent re-entry of the Expedition 47 crew as an example. Tim Kopra, Tim Peake, and Yuri Malenchenko recently returned to Earth from the International Space Station on the Soyuz spacecraft. Upon descent, the Soyuz starts slowing down from 17,500 miles per hour with a de-orbit burn to enter the Earth's atmosphere. Once the descent module reaches entry interface, or the edge of the atmosphere, friction from the thick atmosphere heats the outer surfaces of the vehicle and slows the vehicle for 8 minutes, all the way down to about 515 miles per hour. Then the parachutes and the landing engines do the rest. While the heat on the outside can get up to 3,000 degrees Fahrenheit, the temperature on the inside is maintained between 78 and 80 degrees through the cooling systems hooked up to the Sokol launch and entry suits that the crew wears during descent. Keep sending us your questions and comments using the hashtag #SpaceToGround. We'll see you next week.